class, so today we're going over section 6.2 where we talk about larger systems of linear equations. If you remember from last time, we talked about systems of two variables and we looked specifically at just looking at two different equations. So we had two equations with two variables and we solved those through substitution and elimination. Those were two different methods. Well, now, what if we had more variables and what if we had more equations? What would that look like for solving them? Well, if we did our same processes that we did last time of substitution and elimination, those would work, but they would take a long time and a lot of steps and would probably lead to more like simple algebra mistakes. So we can do the same thing, but we're going to use a different tool or technique. So we could solve our systems and use this procedure right here where we interchange any two equations. We multiply an equation by a non-zero constant. We replace the equation in the system by the sum of itself and a constant multiple of another. These are all things that we did when we were doing elimination and substitution. So these are all legal things. But now, instead of using the equations themselves, we're going to take them and plug them into a matrix. Now, a matrix is just a way of notating our equations. So it's just to help us keep organized. So it's a rectangular array of numbers consisting of horizontal rows and vertical columns. And the plural of matrix is matrices. So we can write the following system in a matrix, and we do that by writing down in a column the coefficients of a variable. So this would be x, y, z, then the answer, and then each row represents an equation. So if we label them, so the first column corresponds to our x values. So we'll write x up here. And then the second column is going to correspond to our y values. Our third column, our z values. And then our answer. Okay? And then each row is going to correspond to an equation. So I'm going to number them over here. So we have 1, 2, 3. So the first row, second row, third row. And we're going to write down each coefficient. So our x coefficient in the first equation is 2. So we put that in the first spot. Then next we're going to go to our y coefficient, which is 1, our z coefficient, which is -1, and our answer, which is 2. And then we'll do the same thing for the second equation, but now we're going to write it on the second row. So our coefficient for x is 1, our y is 3, our z is 2, and our answer is 1. Lastly, we'll do the third row, which is our third equation. And our x coefficient is 1, our y is also 1, our z is also 1, and then our answer is 2. So we've just made a matrix which corresponds to this system of equations. See, the matrix just looks at the coefficients of our equations. Okay, let's try again with another example. So now we have these three equations. We have 2x minus 2y plus z equals -6. We have 3x plus y plus 2z equals 2. We have x plus y minus 2z equals 0. So I'm going to take this first equation and I'm going to write its coefficients and go across. So we have 2x, we have minus 2y plus 1z equals -6. Okay, now when I look at my second equation, we have 3x plus y plus 2z equals 2. And now for our last one, we have x plus y minus 2z equals 0. See, we just found the matrix for this systems of equations. Notice that each row corresponds to the coefficients of the given equation, and each column corresponds to the variable. So these are all my coefficients of x. These are all my coefficients of y. These are all my coefficients of z, and these are my answers. Why don't you try one on your own?